Welcome class. Let us continue with exercise 6.3 question number 4. Please keep your books with you before the starting of the chapter. In the given figure, QR upon QS is equals to QT upon PR is given and angle 1 is equals to angle 2. We have to prove over here the triangle PQS. This triangle PQS, is similar to triangle TQR. That means this small triangle is similar to triangle TQR. Let us begin with the proof over here. In the proof, we are going to take first of all triangle PQR. So we will write in triangle PQR, angle 1 is equals to angle 2, which is already given. Angle 1 is equals to angle 2 is given. Then, if angle 1 is equals to angle 2, PQ will be equal to PR. PQ will be equal to PR. The sides PQ will be equal to PR. Why? Because we know the sides opposite to the equal angles are also equal. Here you will mention the reason. Sides opposite to equal angles. Sides opposite to equal angles are equal. Therefore, PQ is equals to PR. Also, from the question it is given that QR upon QS is equal to the ratio of QT upon PR is equal to the ratio of QT upon PR. This is given. So we will write in the bracket as mentioning in the reason that it is given. Now, also we can write that we know since PR is equals to PQ, we are going to replace PR by PQ. So this same ratio we are going to write it as QR upon QS is equals to QT upon PQ is equals to QT upon PQ. Since PQ is equals to PR. Since PQ is equals to PR. So now we have in triangle PQS and triangle TQR, we have proved that QR upon QS is equals to QT upon PQ. This is proved now. This is proved for both the triangles, which implies, next line we are going to write over here, which implies that QR upon QT is equals to QS upon QP. QR upon QT, what we have done children over here, this we have already proved. We have just shifted QT to LHS and over here we have shifted QS to RHS. So here we have QR upon QT, which is equals to QS upon QP. Now we have angle 1 is equals to angle 1. This is common in both the triangles, you can see. We are talking about triangle PQS and triangle TQR. Both the angles are common. Therefore, these two triangles are similar. Therefore, triangle PQS is similar to triangle TQR by which criteria? By SAS criteria. By SAS criteria, that means side angle side, we proved that these two triangles are similar. Let us move on to the next question. Our next question is question number 5. It says S and T are points on sides PR and QR of triangle PQR such that angle P is equals to angle RTS. Show that triangle RPQ is similar to triangle RTS. Here we are given that angle P is equals to angle RTS. We have to prove that triangle RPQ, that means the bigger triangle, is similar to the smaller triangle. So in the proof we are going to write that angle P is equals to angle RTS, that is given, right? Also, we have one common angle in both the triangles, that is angle R. Angle R equals to angle R. We are going to write over here common. Then you can see that the two angles are common or the two angles are equal. So by double A similarity criterion, we can say that if two angles of one triangle are respectively equal to two triangles of another triangle, then the two triangles are similar. Therefore, we will write triangle RPQ is similar to triangle RTS by double A criterion. Hence, proved. This completes your question number 5. Let us move on to question number 6. It says in the given figure, if triangle ABE is congruent to triangle ACD, show that triangle ADE is similar to triangle ABC. So in the proof, first of all given, we will write that triangle ABE, this triangle ABE is congruent to triangle ACD. ACD. We have to prove, to prove we will write triangle ADE is similar to triangle ABC. The smaller triangle is similar to the bigger triangle. Let us start with the proof. We will write the first line, triangle ABE is congruent to triangle ACD, right? This we all know. Then we are going to write that AB is equals to AC and AE equals to AD. That means over here when the two triangles are congruent, the sides AB is equals to AC and AE is equals to ED, right? Because in triangle ABE and triangle ADC, over here they are congruent, so this is a possibility. Also talking about the ratios, we can write over here that BA upon AC is equals to 1, BA upon AC is equals to 1 and AD upon AE is equals to 1. Why? Over here if you see children, AB is equals to AC. So either you write BA or AB upon, if you substitute the value of AC with AB here, so AB upon AB you will get 1. Similarly, you can see AE is equals to AD. So in whichever case, if you substitute AE by AD, so AD upon AD will be equal to 1. So from here we get AB upon AC equals to 1 and AD upon AE is equals to 1. Now next we are going to talk about in triangle ADE and triangle ABC. In triangle ADE and triangle ABC, we have AD upon AE is equals to AB upon AC, right? If you see over here children, if you see this part, both the ratios AB upon AC equals to 1 and AD upon AE is equals to 1. Now if both are equal to 1, from here what do we imply? That AB upon AC is equals to AD upon AE, because the ratio is 1, therefore these both the ratios are equal. So in triangle ADE and triangle ABC, AD upon AE is equals to AB upon AC, we have proved. Also if you see the diagram over here children, This angle A is common in both the triangles ABE as well as angle ABC. So here we are going to write angle A is equals to angle A that is common. Angle A is equals to angle A which is common. Therefore, this criteria, the similarity is proved by the side angle side criterion. Okay, so we will write over here triangle ADE is similar to triangle ABC by SAS, by side angle side criterion. In side angle side criterion, if you see the statement, it says if one angle of a triangle is equal to one angle of the other triangle and the sides including these angles are proportional, then the two triangles are similar. So here we have proved, over here we have proved that the sides are in proportion. Okay, and one angle is equal to the other, that means angle A is common, so they are naturally equal. So over here by SAS the theorem is the question is proved. Okay, so this is your complete solution. This is your complete solution. Let us move on to the next question. Our next question is question number 7. Here they are saying in the given figure altitudes AD and CE of triangle ABC are intersecting each other at point P. We have to prove the four following triangles are similar. The first one is we have to prove that triangle AEP is similar to triangle CDP. First of all, let us see the diagram. Triangle AEP, this triangle AEP is similar to triangle CDP. So let us begin with the proof over here. Now, over here we will write, firstly we can say that angle AEP is equals to angle CDP. That is, each is 90 degree. Each angle is of 90 degree. Also, we can say that angle APE is equals to angle CPD. Why they are equal? You must know by now. Vertically opposite angles. Vertically opposite angles. Okay. Now, we have proved that both the angles are equal. Therefore, by AA criterion, now what does the AA criterion say? That if two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. By AA criterion, we have triangle AEP is similar to triangle CDP. I'm sorry children, this is CDP. Okay, so hence proved. Hence proved. Like this, you will do the rest of the three as homework. Second one, third one, and the fourth part of question number 7 is your homework. It is very easy children. You just have to use the brain. And I will also give you a hint. You can prove all these three with the help of AA criterion. Now let us move on to the next question. Question number 8 states that E is a point on the side AD. E is a point on the side AD produced of a parallelogram ABCD. So this is your initial parallelogram ABCD where E is the extended point from AD. And BE, this point from B to E, it intersects CD at F. Okay, ABCD is a parallelogram. If we join the points from E to B, it will intersect CD at point F. We have to show that triangle ABE, we have to show to prove triangle ABE is similar to triangle CFB. Now let us see which two triangles we're talking about. Triangle ABE. This bigger triangle is similar to triangle CFB. Where is CFB? Here. This smaller triangle. Okay? Is that clear, children? Let us begin with the proof. We will write in triangle ABE and triangle CFB, we have angle 1 is equals to angle 2. Angle 1 is equals to angle 2 and angle 4 is equals to angle 3. Why, can anyone tell me? Angle 1 is equals to angle 2 and angle 4 is equals to angle 3. Angle 4 is equals to angle 3. They can be termed as alternate interior angles. Alternate interior angles, right? Now you see angle 1 is equals to angle 2. These are parallel lines and this is the transversal, you can say. So angle 1 is equals to angle 2 and angle 3 is equals to angle 4. Here angle 3 is equals to angle 4, therefore alternate interior angles. Now over here we have proved that the two angles are equal. So here we can write by AA criterion, triangle ABE is similar to triangle CFB. Hence proved. I hope this is clear, children. This is your complete solution. This goes your complete solution. Let us move on to the next question. Question number 9 says, in the given figure, ABC and AMP, here you can see ABC and AMP are two right angle triangles at B and M respectively. Prove that the first part is triangle ABC is similar to triangle AMP and the second part is CA upon PA is equals to BC upon MP. So let us see the first part. Triangle ABC, we are going to write in triangle ABC and triangle AMP and triangle AMP, we will write angle B is equals to angle AMP. Angle B is equals to angle AMP. Why? Because both are 90° each, right? Both are 90° each. Also over here, one angle is common. Which angle is common in both the triangles? Angle A. So angle A is equals to angle A. Over here we will write common. So this by double A criterion, we can say triangle ABC is similar to triangle AMP. This proves the first part. Now let us move on to the second part. Here the second part is saying that we have to prove CA upon PA is equals to CA. Where is CA? This side. CA upon PA is equals to the ratio of BC upon MP. Where is BC? Here. This is BC upon MP. Okay, we have to prove that these two sides are, that the proportion of these two sides are what? They are equal. Now, we have proved in the first part, we will write over here, we have proved in part 1, that triangle ABC is similar to triangle AMP. Okay, we have proved that triangle ABC is similar to triangle AMP. Now, if you go through the basic concept of similarity, over here we know that the corresponding angles are equal and the corresponding ratios are equal. So, if the triangles are same, then we can simply say that CA upon PA is equals to BC upon MP. Reason being that the ratio of the corresponding sides ratio of the corresponding sides of similar triangles of similar triangles. This is the criteria, isn't it? If you go through the basic concept of criteria, children, if you look in your books, I will tell you the page number also as well. Page number 129, you can see criteria for similarity of triangles. It's written, we stated that two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. Now, since the triangles we have already proved they are similar, therefore the corresponding sides will also be in the same ratio. So, this completes your question number 9. Let us move on to question number 10. Question number 10 says, CD and GH are respectively the bisectors of angle ACB and angle EGF such that D and H lie on sides AB and FE of triangle ABC and triangle EFG respectively. If triangle ABC is similar to triangle FEG, show that we have to prove the first part, that CD upon GH is equal to AC upon FG. This is the first part that we are going to prove. Also, it is said that they are the angle bisectors. CD and GH are the angle bisectors. That means angle 1 is equals to angle 3 and angle 4 is equals to angle 2. So in the given part, you will write three things. Triangle ABC is given and triangle EFG is given. CD is the perpendicular bisector of angle ACB, which implies angle 1 equals to angle 3, and similarly angle 4 is equals to angle 2. So let us start with the first part. We will write triangle ABC is similar to triangle FEG. This is given in the question, right? Triangle ABC is similar to triangle FEG. Now, this implies what? This implies that angle A is equals to angle F. This implies angle A is equals to angle F, because the triangles are similar, so the angles can also be the same. Angle A is equals to angle F. Angle B is equals to angle E. Angle B is equals to angle E. And we know that angle C is equals to angle G. So over here, when the two triangles are similar, corresponding angles are equal. Also, we know that the corresponding sides are also in the same ratio. That means AB upon FE is equals to BC upon EG, which is equals to AC upon FG. Yes, when the two triangles are similar, corresponding angles are equal and the corresponding sides are in the same ratio. So over here in the first part, we will write in triangle ACD, and triangle FGH, angle A is equals to angle F, which is given because the two triangles are similar. So naturally it is already known that angle A is equals to angle F. Also, we can write angle 1 is equals to angle 2. Why? If now let us listen to this carefully, children. Angle C is equals to angle G. Okay, this angle C is equals to angle G. Now, if both the angles are equal, then naturally half of the angles will also be equal. So from here we can say that angle 1 is equals to angle 2. So over here we will write that as angle C as angle C is equals to angle G. That means if the full angle is equal, the half angle will also be equal. This implies that from here we will shift down and we will write over here. This implies that triangle ACD is similar to triangle FGHY, because here we have already proved that the two angles are equal, and when the two angles are equal, the triangles are similar by AA criterion. By AA criterion, here we have proved that the two triangles are similar. Okay. And if two triangles are similar, then what happens? The ratios are also same. That means CD upon GH is equal to AC upon FG. Here also we are going to write the reason, same reason, corresponding sides corresponding sides of similar triangles are equal in proportion, are equal in proportion, or are equal in ratio. Okay, so this completes your question number 10, the first part. This completes your question number 10, the first part. Okay, this completes your first part. Now children, question number 10, the second part and the third part is your homework. I hope you will be able to do it very nicely. With regard to the first part, you can use the proof of the first part and use it in second, and with the proof of the second part, you can use it in the third part. So with this, we complete today's class. Thank you so much children. Have a nice day.